Okay, I'm going to work through one example of the combination circuits quiz. In this example, we have two parallel circuits of two resistors each, R1 and R2, and R3 and R4. And those two are in series with each other. The values are 15, 20, 25, and 30 in this example. We have a battery, and the battery voltage is given in the problem to be 120 volts. Yours may differ. And there's a switch, which really doesn't come into, it doesn't really matter. We're going to assume that it's closed for current purposes, and that's it. So the first thing to do is figure out these two separate parallel circuit values. So to do that, I'm going to let me just label this A and B for convenience. You don't need to do that. But this one we'll call RA. So 1 over RA is going to be equal to 1 over R1 plus 1 over R2. So 1 over R1 will be equal to, or pardon me, RA will be equal to 1 over 15 plus 1 over 20. And get the calculator out. 1 divided by 15 plus 1 divided by 20. And we end up with 0.1167. Now remember, that's 1 over. So RA is equal to 1 over 0.1167. And so we get 8.57 ohms. So this is my value for RA. For RB, we do that similarly. 1 over RB is equal to 1 over 25 plus 1 over 30 ohms. So 1 divided by 25 plus 1 divided by 30. And I get 0.0733. So RB is equal to 1 divided by 0.0733. And I get 13.64 approximately, with some rounding, ohms for B. Now, the next thing I need to do is I have A and B and they're in series. So to get the total resistance, I just add those together. So total resistance is going to be equal to 8.57 plus 13.64. And I end up with 22.21 ohms. So this is my total resistance. I can substitute that in here, 22.21 ohms. And I can use that to solve for the total current now. 120 divided by 22.21 ohms means that the total current is 5.40 amps. The next thing I want to do is I want to solve for the individual voltages, the voltage at R1 and R2, and the voltage at R3 and R4. So the voltage at A and the voltage at B. I know that it'll be the same for R1 and R2, and it'll be the same for R3 and R4, but it'll probably be different between A and B. So how do I do that? What I need to do, I'll recognize first that these and these are going to be the same. And also that these two have to add up to 5.4, and that these two have to add up to 5.4. Because the 5.4 amps is coming from the battery, and it splits, and then it comes together, and now it's 5.4 again, and then it splits, and it comes together, it's 5.4 again, and goes on back to the battery. But let's look at these voltages. I know that A, this voltage, I know that this resistance is 8.57 ohms. And I know that this resistance is 13.64 ohms. So if I have a resistance and I have a total current, I can get a voltage. So this resistance, 8.57 times my current of 5.4. So I'm going to say the voltage at A is equal to the current at A times the resistance at A. So it's going to be 5.4 amps times 8.57 ohms. So that's going to be equal to 46.28 volts. So I have 46.28 volts, 46.28 volts. That should, if I subtract from 120, give me the voltage at the other point. But let's go on and do that anyway. Voltage at B is going to be equal to the current at B times the resistance of B. The current at B is the same, so it's 5.40 amps times 13.64 ohms. So 5.40 times 13.64, and I get 73.66 volts. 73.66. 73.66. Now, if I add these two together, I should get 120. 73.66 plus 46.28, and what I get is 119.94. So there's a little bit of rounding in that fifth significant figure. It shouldn't really affect your answer too much. So I know that the voltage at 1 and 2 are the same, and at 3 and 4 are the same. The last thing I need are the final currents here. And these currents are pretty straightforward. Now that I know the voltage and I have the original resistance, I can solve each one separately as if it was just a resistor all by itself. So I have 46.28 volts divided by 15 ohms. And the current flowing through this resistor is 3.09 amps. So it'll be a little bit less than the other, 46.28 volts divided by 20 ohms, and I have 2.31 amps, and these two numbers should add up to 5.4. All right, I can do the same thing here. 73.66 divided by 25 ohms, and I have 2.95 amps. 73.66 divided by 30 ohms, and I have 2.46 amps with a little bit of rounding. And so because of the rounding, this is going to add up to 5.41, but pretty close to 5.40 and 5.40 there. Okay, so again, the best procedure is to solve for the parallel circuits as if they are a single resistor, and then you can treat them as two resistors in series. If you're looking for one of these resistors, so one of these guys, then what you have to do is solve for everything else, like the total current. For instance, if I know the total current flowing through this circuit, and I don't know resistor 4, but I know the voltage across B, then I can solve for the current flowing through 3, and whatever is left must be flowing through 4. So then I know the current, I know the voltage, and I can calculate the resistance. Okay, so solve for the things you can solve for first, and then back out the others.